Dear students, Salam Alaikum. This is topic 3 Integration by Substitution of MATH200 Calculus 2 Spring 2020-21. In this topic, we'll be learning one of the very first techniques of integration. In the initial topics, we had direct integration. We had to just remember those one page of 13 formulae and use them one by one and do the integration. Now, in practice, your problems of integration will not look like what you have in that one page of 13 formulae. You'll have to make some transformations in the integrand in the question so that in the after one or two steps your the problem will start looking like the one page of those 13 formulae. Now, the first technique in this process is running the chain rule backwards. Now let's recall that integration of x power n is x power n plus 1 divided by n plus 1. Or we can say derivative of x power n plus 1 over n plus 1 is x power n. I am omitting the c and it is understood that n is not equal to minus 1 in this example. Now the chain rule from calculus 1 is d by dx. The derivative of u power n plus 1 whole power n plus 1 is u power n into du by dx. See, when you differentiate a function u with respect to x, you will get an extra piece called du by dx. Here it is dx by dx and dx by dx equal to 1. So 1 is sitting here which we do not talk about. It is x power n into 1. But here it is u power n into du by dx and du by dx is not equal to 1 unless u equal to x. That's the only situation when that happens. Now this integral we can write it like this: u power n into derivative of u into dx, or which is equal to u power n du, and the answer is u power n plus 1 over n plus 1. See, here we are just changing the variable. Instead of x power n, we are saying it u power n. There is not a new formula here. This formula we have seen before. Integration of x power n is x power n plus 1 over n plus 1. And here we are writing it as u power n du. Here it was dx, here it is du. Which is, and the answer will be the same, u power n plus 1 over n plus 1 plus c. Now, in this chapter, you will be given questions in x. You will change to u, variable u, then do the integration and go back to x, because the question will be in x, so the answer should be in x. So let me repeat how the substitution rule looks like. You have two functions. You have a compound function f of g. Your f is your main function. The argument of f is another function g of x, and next to f you have the derivative of g dx. Or you can say you have f of u, derivative of u into dx. U prime is derivative of u. So you can also write it as f of u du. Now u is equal to g of x for short. So this is it. Now in this table we have some examples. These are not your problems. These are your examples, where you will see how to decide what is u, what's the derivative of u, and how the answer looks like. We are not worried about the exact answer in the last column. We are more interested in finding the function u in order to carry out the integration. So you have f of u, derivative of u dx is equal to f of u du. If the derivative of u is not present here of the function u, then we cannot use the techniques which we are going to use today of substitution. We'll need some other techniques. So now let's start with the first example. You have x square plus x whole power 3 into bracket 2x plus 1 dx. Now here what's happening is your main function is f, which is power 3, and u equal to x square plus x. What is inside? And derivative of u is 2x plus 1, which is sitting next to the inside the function. Not inside the function, inside the question I should say. So you have power 3 of u power 3, and the derivative of u is sitting here. And you will get the answer here in the last column. Do not worry about the answer. We are just looking at these examples in order to understand how to decide what is u. These are examples, these are not questions. Example 2. You have bracket power 5 into 6x square plus x. Now what is inside the bracket? It is u equal to 4x cube plus x square. When you differentiate u, you will get 12x square plus 2x. Take 2 common, you will get 6x square plus x. And this 6x square plus x is present in the question. So you have u power 5 into derivative of u. See, this 2 is multiplicative, and all numbers multiplying or dividing will get adjusted in your steps. So you don't have to worry why this 2 is not here and why this 2 is here. It will get adjusted in the steps. We have seen these questions and this type of questions before in the last week, and today I am repeating this table for you here. Now let's look at the third example. 7x into square root of 1 plus x squared. So what's the function f here? Function is the square root function, which is power half, and the argument of the function is u equal to 1 plus x squared. Derivative of 1 plus x squared is 2x, and here you have the 7x and here you have the 2x. The 7 and the 2 will get adjusted in the steps. What is important is you have the x here in the question. If this x is not there, then your answer will look different, and you have to use a different technique which we'll learn after 2-3 weeks. Example number 4. You have 13x over square root of 1 plus x square. Now what's the function here? It again, your f function is power function, n equal to minus half, and what is inside the square root, which is u equal to 1 plus x square. So the argument of the function f is u equal to 1 plus x square, whose derivative is 2x, and the x is sitting here in the numerator, and this 13 and 2 will get adjusted in the steps. Now how do the answers look? We can think about it. In the first case it was power 3, so your answer will be power 4, and this 1 over 4 will come from your integration. Then in the second example it is power 5, so you have power 6 in the answer, and you don't have 1 by 6, you have 1 by 12, because we have this 2 coming from the factorization here. We have done incomplete factorization. In the third example it is power half, so you can expect power 1.5, which is 3 over 2, and the outside numbers will get adjusted in your steps. Fourth example it is power minus half plus 1 is half, so your answer is bracket power half, and this 13 comes from the steps. Now the fifth example is again the power function. You have 5x divided by bracket 1 minus x square whole power 9, and inside the bracket you have the argument u equal to 1 minus x square. The derivative is minus 2x. Here the power is minus 9. After all the steps is minus 9 plus 1 is minus 8, so you have power 8 in the denominator in the answer. We'll have to write down and get the, in order to get this correct numbers like 13 in the fourth example, or 7 by 3 in the third example, or 5 by 16 in the fifth example. Now the sixth example is 3x over 1 plus x square. Now here the power is minus 1. We cannot use the basic formula. We have to think about a new formula, because division by 0 is not allowed. So we'll get the logarithm natural, or it is the ln function. And the derivative of the argument here is u equal to 1 plus x square, which is 2x. Here you have 3x, here you have 2x. These 3 and these 2 get adjusted when we execute the steps, and your answer will be logarithm natural 1 plus x square inside, and this 3y2. And the plus c is always there. Now the seventh example, we have sine x cosine x. Derivative of sine is cosine, derivative of cosine is minus sine. So if one decides to choose u equal to sine x, then the answer will be half sine square x. And if one decides to choose u equal to cos x, the answer will be minus 1 over 2 cosine x square, minus half cosine square x. And the two c's will have to differ because the answer looks different, so the c's are also going to be different. Now let's look at the eighth example. Cos power 8 x into sine x. Derivative of cosine x is minus sine x. So you have u power 8, and u equal to cosine x. And you will get u power 9 as the answer. It is cosine power 9, and this minus 1 over 9 will come with your steps. You have to do the steps very carefully so that you get the correct number with the correct sign. Now the 10th example. It is 6x squared plus 5 into cosine 2x cubed plus 5x. Now the argument of the cosine is u equal to 2x cubed plus 5x. You differentiate it, you will get 6x squared plus 5. So this will become cos u. And what is sitting as a coefficient of cosine? It is 6x squared plus 5, which is the derivative. So here you have cos u, u prime dx. All the questions have this structure. You'll have some function with u prime dx in the question. And the derivative of integration of cosine is sine plus sine, not minus sign. When you differentiate cosine, you get minus sign. When you integrate cosine, you get plus sign. So here the answer will be sine with the same argument. See, the argument will be the same as in the question. Here in the bracket of the cosine, you have 2x cubed plus 5x. Here also in the bracket of the sine, which is the argument of sine, it is 2x cubed plus 5x. The argument is not going to change. U is fixed throughout. Now, 11th example is x into e power minus x squared. This function has a name. It is x e power x minus x squared is called the Gaussian. It is the exponential minus x squared. Now, u equal to minus x squared, du by dx is minus 2x, and the x is sitting here. You have to manage the minus 2, and your answer will be minus half e power minus x squared plus c. 12th example, cosine x exponential sine x. Put u equal to sine x, you will get the derivative is cosine x, which is present in the question. So you have e power u du dx. And your answer will be e power u, which is e power sine x. See, in the last step, you have to put back the x in all the questions. Now here you have 13th example, ln x whole power 5 over 1 over x into 1 over x. Now it is u, the function is power 5, and the argument of the function is u equal to ln x, and the derivative of ln x is 1 over x, which is very much present in the question. So your answer will be u power 6 over 6. That's it. So we can write many more examples. There is no need. These examples are help you to understand what the function u is, how to choose the u, and in the following 15 examples, we'll see how to carry out the steps. We have already seen most of these questions, but I just will be repeating them again, what we did in the class in this video. This video has nothing new. And in this chapter and in this semester, we'll be making only substitution one time. In complicated questions, we have to make 2-3 times. One time you substitute u, again you have a difficult integral, then you make another substitution v, then w. The process goes on. But in this semester, we'll manage with one single substitution throughout, inshallah. Now let's look at the examples. Example 1. Evaluate the integral x square plus x whole power 3 into bracket 2x plus 1. Now put u equal to x square plus x. Derivative of u is 2x plus 1. So now you can carry out the integration. It is u power 3 du. Now what's the rule of integration? It is u power n plus 1 divided by n plus 1. N equal to 3. You'll get u power 4 over 4, which we can write as 1 over 4 u power 4 plus c. Now please remember to write plus c towards the last step. And your main answer is, not main, the answer is 1 over 4 x square plus x whole power 4 plus c. You can check the answer by differentiation as seen in this example. In this example, I will differentiate, but not again and again. You'll get this 4 will come out. You'll get 1 over 4 into bracket power 4 minus 1 into bracket into derivative of the bracket. You'll get x square plus x whole power 3. 4 minus 1 is 3. Derivative of x square plus x is 2x plus 1. This 1 by 4 into 4 is 1. So the 4 gets cancelled out. And we started with this integration of this, and that's what we have over here. See, it's good to differentiate and check the answers, particularly if the question is long, and one can make some mistakes in the numbers or in the function itself. So it's good to check the answers. Now, next example is evaluate the integral x cosine x squared dx. Now, the main function f is cosine, u equal to x square. So, put u equal to x square. The derivative is 2x, du equal to 2x dx, x dx equal to du by 2, which is half du. See, this step is very important. It is helping you to fix the number which is 1 over 2 in this case. Now, your integration is x cosine x square dx. Now, write the x on with the dx, you'll get x dx and cos x square. So this is cos u, x dx is half du from the steps, fourth steps here, fourth step. There are totally 4 steps here for fixing the numbers. Please write them and do it. Don't try to do them in your mind. You can make a mistake. Now this half is multiplicative constant. It comes out. You'll get integration of cos u du, which is half sine u plus c. Now put back the value of u, you will get half sine x square. Now you can again differentiate and check the answer. Now the next example is evaluate the integral sine x cos x dx. Now this we have seen in the table. We can do it in two ways. Derivative of sine is cosine and derivative of cosine is minus sine. So let's do first u equal to sine x, du equal to cos x dx. Here there is no number to be adjusted because the 1 gets adjusted by itself. If you divide something by 1, you'll get back the same thing. If you multiply the same thing with 1, you'll get back the same. So sin x cos x dx is integration is u du. Now here the power is 1, so it is u power 1 plus 1 divided by 1 plus 1. You have u square over 2 or half u square. It's better to write this u square over 2 as half u square because u can be a very big function. So that half looks better if it is written like this. You have half sine square x plus c. Now somebody might say that no, let's put u equal to cosine x. That is also correct. You will get du equal to minus sine x dx. You have to be careful about the minus sign here. And you will get minus integration u du, which is minus u square over 2 minus half u square plus c star. We are not going to put back the same c because the two c's have to differ. In first case, the answer is half sine square x. In second case, it is minus half cosine square x plus c star, that is plus c because the two c's are different. Let us see how. Now if you differentiate in both the cases, you'll get back your integrand, which is sine x cos x. In some questions, we have to fix the value of c when additional information is given in the question. So in some chapter, we might need this value of c. In that case, we'll see that the two c's will differ. Because if you are differentiating, it doesn't really matter what the value of c is, but if you are fixing the value of c, then you have to be careful. In the first case, you will get one answer, and another case, you will get another value of c, but they will be related to each other. C star minus c will be equal to half. If the c is 10, the c star will become 10 plus half, which is 21 by 2. But in this chapter, you don't have to worry about the value of c. In fact, in most chapters, you don't have to worry. Only in one chapter, we'll be thinking about the value of c. Now, problem number 1. We had 3 simple examples. Now, let's start doing the problems. Evaluate the integral 4x cube plus x square whole power 5 into bracket 6x square plus x dx. Now, here we have the power function n equal to 5 and the argument is u equal to 4x cube plus x square. We can use some other symbol, but like your textbook will be using this symbol. Now, the derivative of u is 12x square plus 2x. Take 2 common. You'll get 2 into bracket 6x square plus x, and that is what is there in the question. See, we can factorize it more, but we are not going to do it. You can also take x common. You'll get 2x into 6x plus 1, but that is not what we need. What we need here is, as seen in the question, 6x square plus x. So take 2 common and you'll get back what is in the question. In the question, you have the derivative of u. So now you have du equal to 2 bracket 6x square plus x dx. Now this 2 will come on the other side. You will get bracket dx equal to half du, just as before. Now integrate it, you will get u power 5 half du, because this bracket dx is equal to half du. This half is a multiplicative constant, it will come out, you will get half integration of u power 5, n equal to 5, you will get n plus 1 over n plus 1. U power 6 by 6, 1 over 2 into u square, u power 6 by 6 is u power 6 by 12. This 12 can be written as 1 over 12, and the final answer is 1 over 12 u power 6 plus c. Put back the value of u, you will get 1 over 12 4x cube plus x square whole power 6 plus c. See, here we had power 5, so we are going to have power 6, and you will be dividing by 6 also, because the derivative is sitting here, and that other 2 comes from the another mechanism, and you have 1 over 12 and not 1 over 6. See, this number has to be fixed carefully. All these steps are helping you to fix this number. Now this is the integration rule which we are going to use again and again, and trying to write them in every solution of every problem. You can again differentiate in 2-3 steps and check the answer. Now problem number 2. Evaluate the integral cos x e power sin x dx. Now the main function is the exponential function. The argument of the exponential function is sin x. So put u equal to sin x. Derivative of u is cosine x. du equal to cos x dx. There are no numbers here. Everything is positive. The number is 1, which will get adjusted by itself. Cos x e power sin x. The integration will be e power sin x cos x dx. See, we have written first the exponential function, then the cosine, because the cosine and the dx have to be together. So you have e power u du. That's why we wrote cos x and dx together, and du equal to cos x dx. And you have e power u du. And the answer is e power u plus c. Put back the value of u, which is e power sin x. Now let me emphasize one more thing. In the question, the problem, you have cosine x, exponential sin x, and dx. See, when you make the change of variable, you have to fix all 3 of them. All 3 of them are together. So if you forget to write dx here or half or 2 in some other question, then there will be a problem. So you have to fix everything in the question, in your steps. And you can differentiate and check that the solution is correct. Now the next is problem 3. Evaluate bracket power 3 into another bracket dx. Now here the function is power 3, and the argument of the function is u equal to 3x power 4 plus x cube. If derivative of u is 12x cube plus 3x square. And this 12x cube plus 3x square is not present in the question. So first let's take the number common. Take the number 3 common, you will get 3 into bracket 4x cube plus x square. And this 4x cube plus x square is present in the question. So you are home. You don't have to worry about it. Now you have to just decide how to fix the 3. How do you fix the 3? Du equal to du by dx into dx, which is equal to du equal to u prime dx. So it is 3 into bracket 4x cube plus x square dx. Now bracket dx is du by 3, which is 1 over 3 du. In the other questions, it was 1 or 1 by 2. Now it is 1 by 3. It can be any number. Now you have bracket power 3 into another small bracket dx. So it is u power 3 1 over 3 du, because this small bracket into dx is 1 over 3 du. So this 1 over 3 comes out. You have again u power 3 du. See, after some steps, you will get a formula from your page 1, which has 13 formulae. So this is u power 3 n equal to 3, u power 4 by 4, you'll get 1 over 12 u power 4, and this 1 over 12 is written like this. Yes. You have the same integration rule again and again. You can differentiate and check your answer. Now next, evaluate the integral x e power minus x square dx. Now this is the exponential function with the minus x square. This function is called Gaussian, and it comes in some areas of physics and mathematics and engineering sciences. Now u equal to minus x square, because in the exponential function you have minus x square, so put u equal to minus x square. Derivative of u is minus 2x, and du equal to minus 2x dx, and x dx equal to du by minus 2, which is minus half du. Now in the other questions we were getting plus half or plus 1 by 3. Now here it is minus half, so you have to be extra careful. Now write down your integral in two ways. First, just write it the way it is in the question, then put x and the dx together. So you have e power u. Now what is x dx? X dx is minus half du. So put this minus half in a bracket because it's a multiplicative number. So you have to put it in a bracket. It's a negative number. So whenever you see a negative number, just use a bracket. You can open the bracket in the next step. Now the number comes out. To take the full bracket outside, you will get minus half. Now there is no confusion, so remove the bracket when you take the number outside. It is minus half e power u du. This is from one page of formula. It is e power u plus c, and the minus half remains in that form. And put back the value of u, you will get minus half e power minus x square plus c. Again, you can differentiate and check your answers. Now problem number 5. Evaluate the integral 4x into square root of 1 plus x squared dx. Now here the function is square root. Square root means power half. What is inside the square root? It is the argument of the function, which is u equal to 1 plus x square. Du by dx is 2x, x dx equal to half du. We have done this many times before. Now write down your integrand. You have 4x into square root. Take the 4 out. First write the square root, then write the x dx together, and x dx together is half du. So write half du. This half also goes out. 4 into half is 2. Now you have square root of u du. Now put the power half. U power half. This is the same function, n equal to half. Now you have u power half plus 1, which is u power 3 by 2, full divided by 3 by 2. Now this 2 when divided by 3 by 2, you will get 2 into 2, 4 by 3. It is 4 by 3 u power 3 by 2. Now when you have u power 3 by 2, you are going to write it as u power 1 plus half. You will write u into square root of u. This is how it looks nice. So you can write your answer as 4 over 3 bracket 1 plus x square whole power 3 by 2, or you can write it as 4 by 3 into 1 plus x square inside the bracket, then square root of 1 plus x square. Inside the square root there is no confusion, so there is no need to put the bracket. If you so wish, you can put it. You can again differentiate and check the answer. Now problem number 6. Evaluate the integral 6x over square root of 1 plus x square. Now again we have a power function with the square root. Square root means power half, but square root is coming in the denominator, so the power will be minus half this time. Now put u equal to 1 plus x square, du by dx equal to 2x, x dx equal to half du. We have seen this many times before, so I skipped one step. Now write down your integrand 6x divided by square root. Now take the 6 outside and write the x dx together. You'll get 6 into integration of 1 over square root of u into half du. This half comes out. You'll get 6 into half equal to 3. You'll be left with 1 over square root of u, which is 1 over u power half. This is u power minus half. So minus half plus 1 is plus half. Now 3 divided by half is 3 into 2 by 1, which is 6 by 1, which is equal to 6. So you have 6 u power half, which is 6 square root of u. And that is 6 into 1 plus x square whole power half, or you can write 6 into square root of 1 plus x square. You can again differentiate and check your answers. Now problem 7. Evaluate the integral x over 1 minus x square whole cube. Now here the function is again a power function. Power is minus 3, and the argument of the function is also different, which is 1 minus x square. U equal to 1 minus x square. In the previous examples it was 1 plus x square. Now here it is 1 minus x square. Du by dx equal to minus 2x. Du equal to minus 2x dx. X dx equal to du by minus 2, which is minus half du. Now write down your integrand, the complete integral. You'll get 1 over bracket power 3 and x dx are together, which is equal to minus half du. So you have 1 over u cube into bracket minus half then du. This minus half comes out. You have u power minus 3 du. Put n equal to minus 3 n plus 1 divided by n plus 1. You have u power minus 2 by minus 2. This minus half divided by minus 2 is 1 over 4. You will get 1 over 4 u square. Put back the value of u. The final answer is 1 divided by 4 into 1 minus x square whole square plus c. Again, you can differentiate your answer and see that it is correct. Next is evaluate the integral secant squared 7x plus 3 dx. Now, your main function is secant square and the argument is 7x plus 3. So put u equal to 7x plus 3. So your argument should look very simple. It should look like kx or like u. So it cannot look like kx because this 3 is sitting here. So let's put u equal to 7x plus 3, du by dx equal to 7, du equal to 7 dx. Now dx equal to du by 7, this is 1 by 7 du. Now integration of secant square 7x plus 3 dx will become secant square u. How much is dx? Dx is 1 by 7 du. This 1 by 7 comes out. You have 1 by 7 integration of secant square u. If you differentiate tangent, you get the secant square. So your answer is 1 by 7 tangent u. Put back the value of u, you will get 1 by 7 tangent 7x plus 3 plus c. Again, you can differentiate and check the answer. Now problem number 9. Evaluate the integral sine power 5x cosine x. Now again you have a power function and the argument of the power function is u equal to sine x and the power is 5. So du by dx equal to cos x dx equal to du. Everything is positive in this case. You have u power 5 du because cos x dx is du. Now u power 5 plus 1 divided by 5 plus 1, we are using the same n plus 1 rule. You will get u power over 6 and we write it as 1 over 6 u power 6. This is 1 over 6 sine power 6x. See, this power 6 should not be written on the x, it has to be written on the sign. Evaluate the integral e power x bracket e power x plus 2 whole power 4. Now what's your function? The function is the power function. Power is 4, n equal to 4. And what's the argument of the power? E power x plus 2. So put u equal to e power x plus 2. It is exponential x plus 2. So du by dx equal to e power x, du equal to e power x dx. So e power x dx equal to du. This is what you have to conclude in this four small steps. Now look at your integration. You have now write e power x with dx. So you have e power x dx and before that you have the bracket power 4. Now bracket equal to u, so you have u power 4 and e power x dx is du. So you have u power 4 du. N equal to 4, you have u power 4 plus 1 divided by 4 plus 1. U power 5 by 5, which is better written as 1/5 u power 5. And your answer is 1/5 e power x plus 2 whole power 5 plus c. See, the idea is very simple. Just get the idea. Once you decide the correct value of u and do the steps carefully, the plus and the minus, 1 by 2, 1 by 3, 1 by 7, everything will be smooth. Now evaluate the integral x over 1 plus x square. What's your main function? It is again the power function. Power is minus 1. So put and the argument is u equal to 1 plus x square, du by dx equal to 2x, x dx equal to half du. Now you write this integration, write x with dx and we have 1 over 1 plus x square x dx. You will get 1 over u, x dx is half du. This half comes out, you have 1 over u du. Now it is half, power is minus 1. You cannot use n plus 1 rule. You have to use a new function which is the logarithmic function, the natural logarithm ln. It is half ln u. Now those of you who remember the properties of derivatives, if it is n ln a, this n goes inside, you will get a power n. Here it is u power half, so you can write logarithm natural square root of u. So you can write the answer, same answer in two different ways. You'll get half ln 1 plus x square, or you'll get ln square root of 1 plus x square. You have to do this very carefully. If you are not sure, don't take the power inside. Then remember, if this x was not here in the question, we could not have used this technique. We would have used another technique and your answer would have been tan inverse x. And it would not have been the logarithm, it would have been the tangent function. Tangent inverse actually. So you have to be very careful when you are reading the question and what method you are trying. Now evaluate the integral secant squared 3x tangent 3x. What the derivative of tangent? Derivative of tangent is secant square. Don't worry about the 3, that 3 will get fixed. So your u function is tangent 3x and that is tangent power 1, so it is u power 1. That's it. By mistake, if you think your secant square is your answer, is your u equal to secant square, but the derivative of u will not fit. So you have to choose u equal to tangent 3x. There is another choice which I am not going to discuss right now. We'll discuss it in some other topic later on. So u equal to tangent 3x, du by dx equal to 3 secant squared 3x, du equal to 3 secant squared 3x dx. So secant squared 3x dx equal to du by 3, which is 1 by 3 du. So you have write the tangent and the dx together, you will get 1 by 3 du and tangent is u. So you'll get, and this 1 by 3 comes out, you'll get u du. Again, it is power 1 function. So 1 plus 1 by 1 plus 1, you'll get u power 2 by 2. You have u power 2 by 6. The power 2 has a name. You'll get 1/6 u square plus c. And the answer is tangent squared 3x. You can make another choice in this question also, but we'll discuss it later on, not today. So your answer is 1/6 tangent squared 3x. Now evaluate the integral tangent x. Now the bracket is extra. Now there is a 1 sitting here which is not useful because the derivative of tangent is not 1, it is something else. So just remember one piece from your trigonometry, tan A equal to sine A over cosine A. A can be anything. Only thing is you cannot divide by 0, but do not worry about the values of the function. So tangent x equal to sine x by cosine x. Now your main function f is 1 over cosine and the derivative of cosine is minus sine here. So put u equal to cosine x, du by dx equal to minus sine x, du equal to minus sine x dx. So you have a function and the derivative with it. So sine x dx equal to minus du. Please do this very carefully. Let me repeat, u equal to cosine x, du by dx, the derivative is minus sine x, du equal to minus sine x dx, divide by minus 1, you will get sine x dx equal to minus du. Now write your tangent as sine over cosine, and sine you write with the dx, and you write 1 by cos x here. You have 1 over cosine x sine x dx. How much is sine x dx? It is minus du, so I have put it in a bracket. So you have 1 over u minus du. The minus comes out, you have 1 over u du. Now for 1 over u it is power minus 1, so you cannot use the n plus 1 formula. You cannot divide by 0, so you write minus ln u plus c. Here you have to write absolute value because the logarithm is defined only for positive numbers over the reals. If you look at the domain of the logarithm, it has to be positive. So you put that absolute value, what we call it in Arabic as mutlaq. So minus ln u. This minus can be taken inside. I have written a note here. N ln a is equal to ln a power n. And n equal to minus 1, you'll get u power minus 1, which is 1 over u, you'll get 1 over cosine. And those who remember their trigonometry, 1 over cosine means secant. So you can write your answer as minus ln u equal to minus ln cosine x. Those who know their trigonometry can write it as ln secant x tan x. Again, you have to take the absolute value over there. Then you can differentiate and check the answer. Next is evaluate the integral tan square 8x dx. Now, The 1 is sitting here, but that will not help you. Now remember your second identity from your trigonometry course. It is secant square minus tangent square equal to 1 and tangent square equal to secant square minus 1. Now inside you can put anything. So tangent square 8x equal to secant square 8x minus 1. So write down your integral as tan square. This t has to be lowercase. Tan square dx is equal to secant square minus 1 dx. Now you know how to integrate secant square. That is your formula from that one page of 13 formulae. And this there are two things in the integrand. You separate them out. Secant square 8x dx minus the second integral is 1 dx. Integration of 1 is x. Just copy it here. Remember the plus c. Integration of secant square kx is tangent kx divided by k equal to 8. So you have 1 by 8 tangent 8x minus x plus c. You can differentiate the answer and check it. Now problem number 15. Evaluate the integral ln x over x dx. Now put u equal to ln x. Derivative of ln x is 1 by x, which is very much present here. What's the idea? F of u into derivative of u into dx. So f of u is equal to ln x, u equal to ln x, derivative of u is 1 by x, so du equal to 1 by x dx. Now put it in the integration. You have 1 by x dx equal to du, ln x by x, you write ln x into 1 by x dx. 1 by x dx are together and it's equal to du, and ln x equal to u. So u du power is 1. Use the n plus 1 rule. You have u power 2 over 2 plus c. It is ln x whole square by 2, which you can write as half ln x bracket whole square. Or you can open the bracket and write the power 2 on the function. You cannot write the power 2 on the x. You have to write the power 2 on the function. And you can again differentiate and check the answer. We will be trying to do some more examples later on in the semester, but these examples are sufficient for this kind of substitution which we have seen today and in the last two classes in our online teaching. Inshallah, this will be sufficient for this semester. Just remember to differentiate your answers and check them. See you soon in the class, inshallah.